Okay, so I'm not gonna worry too much about it. I'm gonna give you all's test back. And then we're gonna go over them. I tried to be lenient.
I appreciate that. I mean, there's one on there, I had the answers, but I didn't get the bearing and the, azimuth.
I don't weight the test so much that it's gonna, if somebody does bad on a test, that it's gonna, you know, say if they don't do good on any of their tests, maybe they're not good test takers, it's not gonna fail them, or they'd have to do really bad to even get a C.
So, Miss Kathy, is this one of those that's open?
No, that was take home. That was one, there's two others.
So I should have given it to you. Oh, okay.
All right, let's see what I got. So I just wrote what the answer was. Why, do you have a grade on yours in Blackboard? I don't have a grade on my paper. This one's yours, right here, yeah. Yes, no, maybe? Do you have a grade? What? So we're gonna, I'm gonna review as quick as I can. I know y'all really don't need much review on the first couple, like at least the first 5. Does anybody, ones that are in here, do y'all need, out of the first 5, do you need any explanation on those?
I'm good. I'm good.
Yeah.
I think we had it on the last one. How about that simplify? I think some of y'all were scratching your head when I had simplify 269 degrees, 59 minutes, 60 seconds. And I put, that's number 2, and I said simplified. It would be just like if you added 2 together and you got over like, you had 82 seconds, you would know to round up, you're not gonna put it. So I wanted you to take the 60 and make that 0 and put the 1 with the 59 and then round that up to 270. I think everybody got that. First one that I had somebody miss was number 6. And chart. What chart in your book should we be looking at for bearings and azimuths, giving one and converting them back and forth?
123, 124, is it 24?
170. Angle azimuth bearings, 170. I'm all right, page 170. So I gave, I said convert a bearing to a north azimuth angle. I'm going to draw it in first. It's north 27 degrees, 43 minutes, 44 seconds, west. So I knew that was in quadrant 4. So formulas for computing bearing angles from azimuth, that charts for that. But how about if I want to go backwards? So a north azimuth, or an azimuth, means that's the angle that the line makes all the way back around to north. The azimuths are only clockwise. So that means we're looking for that angle. So an azimuth is always north to the line, clockwise. A bearing, so if a bearing is in quadrant 1 or 4, the bearing is the angle it makes from the north. If a bearing is in 2 or 3, the bearing is the angle it makes from the south. So that means that is 27 degrees, 43 minutes, 44 seconds. So now I can look at that. If I know this is a circle all the way around, it would be 360 minus 27 degrees, 43 minutes. And I had 300 degrees, 16 minutes, and 16 seconds. I think most everybody got that, but I kind of want to just kind of redraw it out instead of just seeing the words, and explain what an azimuth and what a bearing is and where that angle is from. Questions? There's something I was going to add to it, but oh well. All right, so this time 7 is similar to this one. I'm going to put 7 right here. But this time we have a north azimuth. So there's my north. So I sketch. Every time I'm going to do something, I'll normally sketch. Which you've got the chart for this one, so it's easy. Or say it's easy. I know what I was going to say. So that's 126 degrees, 21 minutes, 16 seconds. All right, so a bearing cannot be over 90. So if you have a bearing and it's over 90, then you've got something wrong. So a bearing is only going to fit in the quadrant, so it's only going to be 90. An azimuth can be anywhere from 0 to 360 and is always from north. So if I'm looking at that and it's 126 degrees, then I know it's in quadrant 2. So I'm going to look at that chart and say quadrant 2 southeast, the bearing equals 180 minus the azimuth. So I'm going to do my chart. So it's going to be south. I need 2 letters. And it's 180 minus that 126. Because what's taking place is if it's in quadrant 2, the bearing is the angle it makes from the south. So that's what we're looking for. If you know it's a straight line, 180 minus the 164, I meant the 126, will give you what's left over. So I think most people got that one, but I just want to make sure. Questions? Good so far? Move on.
So if it's ever over 90 degrees, you subtract 180 from it?
No, you probably got something wrong.
Yeah. Those are the rules that I'm having issues remembering. When do I subtract or add 180, or it's all like.
If you sketch, so that would be what you're thinking about is when we were figuring out preliminary azimuths to do the traverse. That's in plus 80 minus 180. That would be the rule of thumb for that.
Okay.
And I had y'all do your traverse. When I send you home with a take home, you're not gonna have to do that to it. And I noticed a lot of people did that for the last one, like problem 14, that they did that. So they were getting the azimuth of the line. They were getting the azimuth that I wanted the bearing. So I didn't completely count off altogether. If they had the azimuth, I knew they were trying to get it. So the adding and the subtracting, the 180, that's when you're just trying to figure out preliminary azimuths. But, so it's not a bearing, an angle, or a north azimuth.
Okay, I guess this is just, looking at the one problem and writing the answer down for another one. And this is, it's added the two instead of subtracted.
Is that what you did?
No, that's what you did. This is me right here. I just subtracted it from 90. And you look like you added 180 and 126 to get 3 something. Yeah, you just added the 2.
Where?
Number 7. You're looking at number 6 now.
Oh, yeah, I'm looking at 6 because my 6 and your 6 ain't the same thing. You must have. What did you get for number 6?
332 degrees, 16 minutes, and 16 seconds. But you underline the 16 minutes. Or wait, no, you I think it's just your check.
I got the same thing.
See what you did? Okay, this one should be 180 minus that. So quadrant 2. So we're going to be looking at formulas for computing bearing angles from an azimuth. Quadrant 2, the bearing is 180 minus the azimuth.
Right.
So
I'm just saying that you look like you added these 2 instead of subtracting.
oh yeah.
Oh, okay.
I got
That's
you
all.
now.
That's all.
That actually goes up there.
Yeah. Okay.
Is that your answer right there?
36? No, I just wrote that.
Oh.
Mine is 36.
Okay.
I did it from 90 instead of 180.
Oh, I wrote it on your paper wrong.
Right.
I did. I actually looked at somebody else's on number 8, and I had changed number 8 because we had worked one just like number 8. So I changed it so my paper was different than what y'all had, and I was like, so I started to mark through it and line it up. I was like, ooh, that wasn't it. So we're good so far. Trig, I was very happy with. Actually, I was very happy with 8 and 9. All right, so that's a building. And we got 25.51 feet from the building. That's to a ladder, and the ladder reaches up the building. He wants to know how long that ladder is. The building is 110.49. This is 25. We're looking actually for the hypotenuse. But I did give you an angle. So I threw something, you could solve it, you could have solved it by trig, but I wanted you to see Pythagorean theorem right off, which is your a squared plus b squared equals c squared. So I'm going to go ahead and set it up. And I put this in, I keep forgetting to put the square under when I was solving it too. And then take the square root. So that was 113.3966 feet. That would be your answer. Question? Do you want me to show you how to solve it? Maybe by trig? Or you don't care?
That's how I ended up knowing.
So you could have, so I would have had to say sine, cosine, I'm writing my formulas down. Oscar had a heap of apples. So I could have used cosine of the 77 is equal to, the adjacent one to that is that 25.51, and we're looking for the hypotenuse. And there's probably 3 ways you could solve this problem. We could have done sine of 77 is opposite over hypotenuse, so we could have solved that one multiple ways. We could have done it by sine or cosine. So just make sure it's working out. Cosine. So that's one, so I got the same thing. So what I did is I took the cosine, moved the h over here, 25.51 divided by the cosine of 77. I'll get your testing in just a sec. So that's what you would have. So you could have done, I wanted y'all to see Pythagorean theorem. This is on the final. You want my opinion on it? I would maybe either solve it. I would solve it both ways, and then I could check, make sure I was right. Because I got the same answer. So I wouldn't leave anything unchecked for the final. Because just remember, I mean, I'm going to be honest, this test in the past that you took got classes before. A lot of times I might do a retest on it. But since you will see it on the final, and if your final is better than any of your lowest test scores, I'll replace your lowest test score with your final grade. And I think there shouldn't be any reason why I don't have A's and B's on the final, because I'm going to go over every single thing that, so if I don't go over it, it means it ain't on it. All right. Moving on. Problem 9. So I'm going to sketch it up real quick. So it's a triangle field. They want to know how much fence is needing. So the hypotenuse is given. This It doesn't matter which way you put is angle 40 or 50. Formulas. Sine of the angle. Most of y'all got that one. How do you want to solve for, I'm going to put like letters, A to B to C. So A to C is like our hypotenuse. How do you want to solve B to C? Anybody, how do you want to solve this line?
Cosine.
Okay, you want to do,
I had 50 degrees on the bottom.
okay, so if you do that, then you're actually solving, if you do the cosine of the angle, you're solving for the adjacents, what you're doing. Because for 50,
Right.
the adjacent for the 50 degree is A to B, and this would be the opposite. So you would need to be using sine for that to get B to C.
Okay, to get B to C, but I guess I solved for it.
So here, I'm not even going to use the 40. Watch what I'm going to do. I'm just going to use sine 50. And I know the opposite's what I'm looking for. And I know my hypotenuse. If I say sine 50 and multiply it by the 435.67, that's giving me 333 point, and I'm on 74. And I'm still going to use that 50 degree angle, but I'm going to use cosine. I'm going to solve for the A now. Adjacent over hypotenuse. That's it each. So if I do cosine of 50, so there's my two numbers. So I didn't even use the sine. I didn't use 40. I could have took the sine of 40 is opposite over hypotenuse, and you're going to get that exact same answer. So I could have said sine 40. So the opposite of the 40 is this A to B. The adjacent to the 40, because you're looking at the angle, the line that touches the 40. That's how you know it's adjacent. So for the 40, adjacent would have been B to C, and the opposite would have been.
So for the quadratic or the A squared plus B squared, if we were to do that to find 33, 333, we would do 435 plus 280, both of them squared, and then the square root.
No, so you're saying which one? You had this one?
Right.
Okay, if you had that one, we're going to say that would look like this. You don't know. We don't know this line down here, so I'm going to say B to C. C, the hypotenuse squared. It'd be set up like that. So then this actually would be it'd be subtracted.
That's where I made my mistake, because I just presumed you just use the two knowns to find the unknown.
No, because you remember it's when you're looking at that a squared plus b squared equals c squared, the c is the hypotenuse. So if you've got the hypotenuse, it's going to be by itself over here. So if you've got a hypotenuse in one side, you can solve it that way. It's subtracting. And then you would have to take square root of both. So my other suggestion would be, once I got these two, I would put them in the a squared plus b squared equals c squared and see if I get this. And then that's like a check to where I know that I got the right answer. The two that I solved for, I could put them back in. That would be your two sides, and then I would see if I got the hypotenuse. Have to be like that. So I could plug that back in to find out the hypotenuse. It's supposed to be a plus. As a check, and I'm gonna write check here. As a check.
How did you put it in the calculator? The sine 50, you put 0 divided by 435?
Where at? That's,
I mean, opposite?
yeah. No, you multiply that.
Okay.
Sine 50, because this is over here, and to get it over here, you have to multiply each side by the bottom, by that.
So you multiply each side by 4,
Mm-hmm.
3, hold on, let me, I'm writing wrong. The formula is you multiply both sides by.
So if you're here at this sine 50, and then you've got opposite. Okay, so I want to just solve for the opposite, right?
Mm-hmm.
So I have to multiply both sides by 435/67 to get it to cancel out. So that would cancel. That would cancel. So I'd have to multiply this side times. That's kind of.
So it's 435.67
times.
Sine 50.
Mm-hmm.
Gotcha.
So in other words, to solve for O by itself, you got to get the 435/67 over here. So what you do to one side, you got to do to the other side. So that's how we knew to multiply it, because that's division there. So it's opposite of what it is. If it's underneath here, you're going to multiply it. If it was on top, then when I got right here, how I did that, well, that was the same one. It was maybe the 77 Trig one I did a minute ago.
So what's the?
When I did that one, I put the h over here. So I had to multiply both sides by h. That's how I got my h over here. Cross that out. Now I'm h cosine 77. Well, that's multiplication. So to get it on the other side, you have to divide both by that cosine 77. I don't know what math y'all did that in. That's like a maybe basic algebra. Y'all been doing that all along. Y'all been doing it right. You'll see this kind of stuff right here again, where we're having to solve in like souls and foundations. I know we use like we actually have usually one unknown, and then we're trying to solve for that, so it could be, just like that, so you knowing how to get from one side to the other. We actually will have two unknowns, two equations, and you'll back substitute. And I know you do that in Math 171, so I can, when summertime comes, I'm gonna say, I know you've seen this. Questions on that one? I'm back over here now. There's probably 5 ways you could have solved this one. Probably more than that.
Yeah, 'cause on my paper, you did that, and, I got the right answer, but I did it a different way.
That's fine. So what I'm asking for is how much fencing is required. So some forgot to add all 3 numbers together. Because it says how much fence would enclose. And we worked one just like this in class. That's why I had to change the numbers. Not sure when we worked it, but we worked it. And then the hypotenuse. So the final answer I was looking for was 1,049.45 feet. We good? Let me know and I move on.
The 435. Oh,
That was given.
BC. So you added those 3. So the answer wasn't,
Really the final answer should have been 1,049.45, meaning how many feet of fencing will need to enclose the field. So that's a triangle field. So I gave you the hypotenuse, you had to solve for the other 2 and then add them together. And I will save these PDFs and email them to you too. And the video will be in Blackboard. Ready for 10? 10 was a trick question.
hey, I thought you cleared that.
So I'm gonna write north, south, east, west. It had a bearing, north 50 degrees east. That does not look like a 50. I need to slow down on my. Okay. This was C. This was B. And this was A. And then I gave you so I wanted the bearing from B to A. No, I gave you B to A. I want to know C to B. So what quadrant is this line in? The B to A. 1. So that means that's the 50 degrees there. Now, if you didn't know what quadrant this was in, let's say it was 129, I would just add the two together to find out what quadrant the line was in. But if you added those two together, what did you get?
180.
And then I'm going to look at that, and then I'm going to look at that and say, all right, a bearing can't be over 90, and that's a straight line, so it's going really straight south or straight north, but a bearing needs 2 letters. So I saw it, the whole line was 180. But I really asked from C to B. So what direction is it going if you went from C to B? Not from B to C. Some gave me south 0 degrees east, some gave me south 0 degrees west. You said straight south, but I still want a letter. But the correct one, two that would be for this one, if I'm asking, but I took any of these. Anything that you had, I took it.
I was told wrong.
Okay, so what if this angle was 128? It was 128 instead of 130, so I'm gonna throw another one. So what if this is still 50 and I normally draw the scale, but we're going to see what would I do right here? Add the two together, and I'd probably which would be 178, and I want to know a bearing. So when I knew that, I knew it didn't quite go past the 180 line, so I know it's in that southeast quadrant. So I'm looking for that little bit that's left over, which would be 180 minus 178, which would be south 2 degrees east. So I threw a second one in on you just to get more practice. If you weren't sure, and let's say I gave you 132, and you added 132 in the 50, you would get 182. So that meant it's past that line, so that means it was in the third quadrant. But remember, a bearing can't be over 90. Just throwing some out at you. Again, like I said, I'll review for the final. So all this stuff I'll kind of go back over again. Good? 11. This one got a lot of people. Had somebody had it right and then turned around and marked it out. All right. We know the bearing from A to B. And A to B. Okay. So what that's telling me is that that is 70 degrees right there. When you draw your north, south, east, west. I put right here my axis. I'm looking, this line's in quadrant 2. So that means it's 70 degrees off the south. Remember, every line has 2 directions. There's a reverse bearing. If I was looking at A and going back, that time it's in the fourth. So if you're going from A to B, of course it's in the 4th quadrant. But if you're looking from B to A, that's why it's opposites. They're called reverse bearings. All right, now I gave you this being 220 degrees.
We gotta figure out.
Well, what quadrant's this line in from B to C?
4.
Okay, so that means for the bearing, I'm looking for the angle from north. So I'm looking for that angle.
So we go from C to D, and it's 360 degrees, that's 20, 90, 80.
You want me to tell you what I would do?
I just went the opposite way, but
Okay, well, you could. I would say, okay, if that is 70 from here to here,
20 degrees is 90, then 90.
and if that's 220, I'm going to go ahead and subtract the 220, take the 70 out, and that'll leave me,
Okay, you did the opposite way.
that'll leave me then with this right here. So if I got the blue is 220 all the way around, and the red is 70, if I take that 70 out, that'll give me the angle from south to BC. Minus.
Did the whole opposite way.
Yeah, and you can,
All I
okay.
did was add I know each angle is 90 degrees, so I added the 20 instead of taking away, and made it 240, and then added another 90, and I made it 30, and then it came out to 30 degrees, because a 360 minus 330.
Yeah, you could go the other way.
Yeah, I think the add 220 and 70 and minus 260.
How did you do that?
So I did 220 and 70, and I got 150. And then if this is a straight line and I've got the angle from here to here, that'd be 180 minus 150.
Okay.
And that would be north 30 degrees west. So you could have came, I'm gonna put it on this one. That's 70. And because that's in quadrant 4, I'm looking for this. All right, so I heard you say you went and took the whole 220 out of 360. Is that what you did?
No, yeah, what I did was,
Or did you figure out what this part
we
was?
realized it's 90 degrees each angle, so I put plus 20. And once I did the plus 20, I know it's 90.
Okay,
And then I put the,
so what,
plus 20, because we already know that's,
because that's supposed to be 90, so that was 20 degrees.
and we know that's 90. That's 90 degree angle. So when you add that's 110 plus the 220, that's 330. And 360 minus 330 is 30 degrees.
Okay. So that's how I had some that had 110. I did see 110, and I was trying to figure out how they did what they did. They just put the 90 and the 20 together. So you're still looking for the red. So you could do that. Like I said, so that sounds like how most of y'all were trying to work it. So you said 20 degrees plus a 90, which is the quadrant 1, plus your 220 gave you 330 degrees. And then 360. And it's in quadrant 4, so that would be a north 30 degrees west. So I solved that both ways. So I did see like that 110 on a lot of people's, and I was trying to figure out how they got it, and that kind of answered it. I think they did the AB and they added 180. The next one, I was really pleasantly surprised how well most people did on 12.
Was it a trick question?
No, I just. So A to B to C. Oh man, I really messed up now. Okay, there we go. Oh, man. Me and this one ain't.
Let's put yeah on the wrong one. Got a whole bunch of years. Everything you put yeah, I got wrong.
No, you didn't. If I say yeah, you got it right. Okay, that looks a little better. So this is A, B, C.
So,
So that was the problem. Might help if I put my watch on the right way. Let's see what time it was. I'm gonna, do this one and then I'll check what it. All right, so I'm looking for A, B, and C. I want to know this angle, this angle, this angle. So again, I'm going to go ahead and do my north, south, east, west. So for the, I'm going to do A. So it kind of looks like this. North, south, east, west. Quadrant 1, 2, 3, 4. What quadrant is C to A in? C to A. Quadrant 2. So that means this is 72 degrees. What quadrant is 1 in? Or A to B is in 1. Okay. So that's 32 degrees, 54 minutes, 25 seconds. So if this is a straight line, and you know this, man, I put my hand there.
Add those two together, minus 180.
Correct. So I would take 32 degrees, 54 minutes, 25 seconds, add that to 72 degrees,
27 seconds.
and that would be, how much?
It was 27 minutes, just 72 degrees, 27 minutes.
Right here?
Right.
This problem and me are not getting along. Let's say break time now. 20. Add them together. 20. I'm not, anybody got had it together on their paper?
I just
I just had the answer. I put it all in the calculator. No.
I just minus 180 and.
You just said 180 minus.
Right.
So that's A. And A was 74 degrees. 74 degrees. 38 minutes, 35 seconds. All right. Going to B. I'm going to sketch B up here out of the way. So B to C. Yeah, it might not work out too bad. Looks like this. That's the 32 degrees there. This is in quadrant 1, 2. This one is the 35. So all you would do is add those two together to get the, for B.
So,
So I think this is where Chris was saying, when do you, which, so I'm going to give you a rule of thumb on this one. Okay. If they're in quadrant 2 and 3, you just add them together. If they're in 1 and 4, you just add them together. If they're in 1 and 2, you add them together and subtract 180. If they're in 3 and 4, you would add them together and subtract from 180. So the last one is, they're both in the same quadrant. So any that are in the same quadrant, so if I'm looking for that angle at C, they're in the same quadrant, you just subtract the smaller one from the bigger one. So if they're, this last one right here, they're in the same quadrant. So let me write some notes down. If they're in 1 and 4 or 2 and 3 quadrants, I'm gonna put quadrants. You 180 minus the two angles added together. You add angles. You just add angles. 1 and 4, 2 and 3, you just add the two angles. If they would have been in quadrant 1 and 2, or 3 and 4, you would take 180 plus 180 minus the two angles added together, which is what we did for A. Added. Last one, they're both in the same quadrant. So they're both in the same quadrant. That means both angles are from north. So this first one was 72.27, and the other one was 35. And what you're looking for is the angle in between the two lines, which would be this. So that would be the same if they were both in quadrant 1. That would be the same if they're both in quadrant 2. That would be the same if they're both in quadrant 3. They're in the same, and you're looking for the angle between the two lines. You're just going to subtract the smaller one from the bigger one. Most and I had C as being 36 degrees. 41 minutes, 15 seconds. Okay, break time. We only got 2 left to do. So, Landon, we're reviewing the test. So it's being recorded and I've already worked through problem, 11? Yeah, so I'll just do 12 and 13 last two.
So bad.
Well,
So,
13 and 14. 13, I don't know.
this one?
No, maybe that one.
No, I had it right, but I'm just trying to make the notes neat. Because, you know, it was all over the place. I'm trying to color code.
So let me say this, whatever I review for the final exam,
I don't understand how I got it right and I got it right.
I copied all somebody else's paper.
If I was next to somebody, I would believe that. Like, how did I get it right?
well, I have seen that, happen.
How?
And they were so bad off, I knew they cheated.
Like, got your own dash, your own section, just the one
Yeah.
next to me.
They weren't together, but they used to set like 2 across and 2 that way, so it'd be a pot of 4. But the person they cheated from was, like a 40. So theirs was and they had the exact same answers, and they were so out of the ballpark.
He cheated on the real paper.
Yeah. So they didn't get to do a retest. I'll put it that way. If they tried to do it their own, then yeah, I probably would have let them retest, but I didn't let them retest this. I mean, I saw 2 that had that 110 for that one, but I knew that they didn't, I knew y'all didn't cheat. So, I mean, you're getting your book and your notes. I wasn't sure why some were putting 110. Now I know how they got that 110 for that one.
I write down everything, it is all over the place. And I just need to.
Soon the class is over, you should put your notes together. It's gonna wait.
So this
I literally like
13 is gonna be, it's almost identical to what we just did in 12. 13 was just like 12, but when some of y'all got to 13, you're like, I don't know what that is.
I ain't know 13 or 14, I told you.
But if you got 12, 13 is just like 12.
It just.
I was good with 13, but 14.
It just don't compute right. It just don't. It didn't register. So I need to have like separate. I got 13.
So they were identical. So one of the funny things I saw is, if you look at 13, it says compute interior angles at B and D. B and D.
I got both of them wrong.
Okay, somebody circled the A and at and did the A too. So they solved the word, the A and at, circled at, did D, and I think their A was wrong, but it's cute that they circled it, thinking they had to do A.
I don't know how I got off 0.12. And I got the first one wrong. You told me what. See right there, you said it was 2. I don't know how I got that. I probably broke the number backwards. 2 to 1.
Probably, I don't know.
It was off a second.
Some of y'all were off 10, some of y'all were off, if you're off at one of the D's, and it might be this one, that some of y'all had different answers than I had. Actually, it is 13.
He said, so what's that different answer you got? You're right, that was wrong.
Hey, get back.
Hey.
No mask on, man, get back.
Quick. Okay, so I'm gonna go ahead and say A to B. I didn't count it off. You got that close to it? Okay. A to B to C. And A is north 46 degrees, 14 minutes. And I think this one got most people. They got the one that was in the two opposite quadrants, like the 1 and 4, because they knew to add those two together. So A to B to C. Okay. So I'm going to do my north, south, east, west. Draw my little. This is kind of like that one that was, this is kind of like that one that I was trying to figure out how y'all got the 110. Okay, this is quadrant 1, 2, 3, 4. So remember, the bearing is the angle it makes from either the north or south. So if it's in quadrant 1 or 4, the bearing is the angle it makes from the north. So this, I missed this one is east. So that's in quadrant 1. So that means I know that this angle right here is 87. This one's in quadrant 3. So this is the 46 degrees, 14 minutes, 28 seconds. What I'm asking for is the angle between those two though. So I'm looking for the angle that's between each green line. So there's a couple of ways you could do that. Could you figure out what this is? And then you know this is a 90. And then this is given. So you could add this, the 90, and this little bit. Or this is how I did it. I took, this is a straight line. So I did 180 minus 87 degrees, 52 minutes, 43 seconds. That then gave me this. And then all I had to do is add the two together, those two together to get the total angle. Somebody has their work on their paper while they do it. Wish y'all did your work on another paper. So I saw somebody figured out what this was, that 2 degrees, 7 minutes and 7 seconds. And then they added that plus 90 plus the 46, 1428. So that if you did that, it would be like 90 plus 2 degrees, 7 minutes, 17 seconds. and plus the 46, 14, 28. So that answer was 138, 21. 138, 21, 45. That was B. I'll do 180 minus. If you solve it the way I solved it, or was thinking you could, you would have, I took 180 minus my top angle, left me with what's left over, and then I just add the 46. So there's a couple of different ways to solve this, and I probably should have said, which way do y'all want to solve it? Looks like most of you did it just like this one right here. Am I right? If they got it. You figured out the 2 degrees. Next one should be easier.
Okay, I got the same answer.
Next one should be. And I think most people got the C. North. Okay. And then this one was south 50. Okay. So I'm gonna put down what I do know. Quadrant 1, 2, 3, 4. Quadrant 1, the bearing is the angle it makes from the north. So that means that's 15 degrees, 50 minutes, 51 seconds. Quadrant 4, the bearing is the angle it makes from the north. So that is that angle. And I want the angle between the two blue lines. So that means I'm looking for this. So that means you just add the two together. So remember, 1 and 4, all you have to do is add the two together. 2 and 3, all you have to do is add the two together. So that would have been 15 degrees, 50 minutes, 51 seconds, plus 56 degrees, actually I solved for all of them, and I should have put 2 zeros in there. So the last one is the one that everybody's eagerly awaiting. So this is 4-sided. I'm doing the best to sketch it. Okay. That's A, B, C, D. I gave you so I'm gonna solve it the way most of y'all were trying to solve it. So I'm gonna be going, I'm gonna look back at our notes from chapter, I think it's 10. It might be chapter 7, it's chapter 7. And if we're going counterclockwise, we subtract our equals. I'm going to solve it the way some of y'all were trying to solve it. Let me put it that way. And you would have been right if I wanted azimuths, but I asked for the bearings. Okay, so this was kind of like that online. I gave you problems to work in class for 2 days, and I checked them to see. So I'm going to try to work it over here out of the way. So what would be the azimuth for this line? The azimuth. If it's in quadrant 2 and I have the bearing, what would the azimuth be for that line? So, because I got a bearing on it, so if I'm looking back at the chart that's on page. So I noticed y'all tried to work with north azimuth, that's why I'm going back and doing a north azimuth. What did you do, Ezekiel?
Looks like
Looks like you probably.
27 plus 180.
Okay, so you converted a bearing to an azimuth first. So C to D. You said 180 plus 27 degrees, 09 minutes, 13 seconds. And that would be
207.
207.
Degrees, 13 seconds.
Okay. Okay. So that's the azimuth from C to D. And now I want to go from D to A. So here's the first thing I want to say. Is that greater than 180 or minus 180? Or less than 180?
Minus 180.
Okay, so we're coming back to what we just had.
I subtracted the interior angle first.
Okay, so I'm right here. Now, can we subtract the 53, 38, 30 from this angle? This is the back azimuth right here, from D to C. Can I subtract 3?
189 minus 53, is that what you're asking?
Nope. The 27 degrees, 09 minutes, 13 seconds.
Plus 360.
That's, so I can't, because that would give me a negative number. So remember when we did your traverse around the building and we did that example in the book? If you can't subtract it, you got to add 360 to it. So that would be, and some of y'all had it. You did get it. But again, so if I say 27, that gives me, I add 360. Okay, now I'm going to subtract my angle because we're going clockwise. So you subtract when you're going clockwise. This wasn't my intentions on how you were solving this. So D to A, I think it's going to be 387. I'm going to subtract that 53 degrees, 38 minutes, and 03 seconds. Now solve this on some of your papers. So some had that, but that's the north azimuth, and I asked for the bearing. So you could leave it like that for just a minute, and move on and solve for the next two. If and this is the ones that, if you're given, so that's actually in quadrant 4, because it's 333 degrees, 31 minutes, 10 seconds. So if I wanted the bearing on that line, I'm going to take 360 minus that. That would leave me with moved for me at one time. So it should be north, 26 degrees, 28 minutes, 50 seconds. Do you want me to show you the real easy way to have solved it? I'm going to draw north, south, east, west. What quadrant is this green line in? The 270913. 1. So that means you know that angle right here. If it's in quadrant 1 or 4, the bearing is the angle it makes from the north. So what quadrant is this line in? The one I just put one on it. Let's say you don't know it. What quadrant is that in? 4. So that means we're looking, so that is what we're looking for. If I got the angle from line to line, and I know that this is 270913 from the north, all I'm looking is for that little piece there. So I would say 53 degrees, 38 minutes, 03 seconds, and subtract 27 degrees, 09 minutes, 13 seconds. And that line's in quadrant 4, so I'm going to put a north and a west, and it's 26 degrees, 28 minutes, 50 seconds. Look at all of those calculations, and then we still would have to take 360 minus that. Whereas if you would have just sketched it right there, you would have known. Always put your north, south, east, west. Wasn't that a lot simpler than coming over here doing all of that stuff?
Yeah.
Okay. So I'm just gonna do the plus to go over. So if you get the first one wrong and then you continue on, it's just a domino effect. But you can also check yourself. So I'm just gonna go 1 over, and I'm just gonna put, this is my A, this is my D, and we're looking for B next. So I'm gonna kind of looks like that.
Are you on Blackboard right now?
Yes. I hope I am. I'm hoping I'm recording it. Okay. I don't know. Sometimes I've just had my top of my head in here, or for estimating, I spent 15 minutes recording stuff from home and using my tablet to write on a whiteboard and didn't share the screen, so all they could do is hear me. So every so often I mess up. Okay, let's do this. Okay, so we just solved this. This was the north 26 degrees, 28, my paper hits it. Okay, so we just solved for that. Now we're going to be looking at, so D to A. Ooh,
Yeah, okay.
that was you?
Yeah.
Okay.
Their thing isn't pulling up. I'm the only one that's in the.
Okay, well, I'm glad you can see it, because I was hoping I was recording it. All right, so now I'm going to show you the easy way of doing it. We just found that. Then we're actually going to be looking for this. I want to know what A to B is. Okay. Quadrant 1, 2, 3, 4. Let me give you the angle, write the angle in. That angle is from green line to green line. So I'm going to kind of write 189 degrees. So I'm just isolating this one just to kind of make it. Okay. So what quadrant is A to D in now? One. Okay, so that means the bearing is the angle it makes from the south. Okay. What quadrant is A to B in now? If I'm looking at what quadrant's A to B in. So the bearing is the angle it makes from the north. So I'm just looking for that piece. So I could add this plus the total angle and then subtract out 180 and it'll leave me with what's left over. Or that's what I would say the easiest. In other words, figure out what, add this, the 26, and the whole 181 together. So then that would actually give you from here all the way back around. And then if you know it's a straight line, then you could subtract 180 from it. So this is one of the harder ones. So I'd say 189 degrees. But you had one just like this, like on your home, like this take-home stuff. So I would add those two together. So 189. Plus 26 degrees, 28 minutes, and 50 seconds. So that gave me 216 degrees, 12 minutes, 9 seconds. Now, again, we're looking for a bearing, so you wouldn't just leave it like this because we want to know what the angle is from north to the line. So I'd say so is Chris this one of the ones you're thinking about? What do I do? Add 180 minus 180?
Yeah, it's surprising because I got this one right.
Mm-hmm.
Because I got what I thought was going on right, and then the other ones I didn't because I did exactly this right here.
Okay. So for A to B, I had 36 degrees, 12 minutes, and this was a 9 seconds. But again, you got to put two letters. And west. We good? Go to one more. Which I'll email these to you. You got it written down? Can I go to the B real quick? Yeah, no? Okay. So I'm just gonna make another one to do B, because it's just easier. Okay, so I'm gonna do north, south, east, west. We just solved for B to A, and that was north 36 degrees, 12 minutes and 9 seconds. Okay, and I gave you the angle. Let me go ahead and write this other line. The other line is right there. A, B, C. I gave you the angle. Okay. North, south, east, west. What quadrant is A to B in? 2. So that means that's 36 degrees, 12 minutes, 9 seconds. What quadrant is B to C in? Okay, so that means the bearing is the angle it makes from the north. So that's what I'm looking for. So you've got the angle from south to A and A to C. All I'm looking for is that little piece left over. How would you think you'd solve that? I've got 36, 1209. I've got the angle from blue line to blue line, 58. And I'm looking for.
Add them together and subtract from 180.
Correct. So I'm just going to say 180 minus. So sketching like your north, south, east, west does make a difference. I guess knowing what you're looking for does too. Okay, so that's in quadrant 1. So my 2 letters are north and east. And then that's B to C. So I had 85 degrees, 16 minutes, 52 seconds. So 180 minus those 2 angles together. And now this, that was the last one I needed. But how about checking my work to make sure that I didn't get off somewhere? I would say, because I gave you actually C to D. So let's just kind of do a check. Make sure that we're not. Okay, so this is C. This is B. This kind of goes off more at an angle, but. And kind of looks like that. This one kind of really comes out more. So this is just my check to make sure my math is right. This is like 85 degrees. You know it's over here. So north, 85 degrees, 16 minutes, 52 seconds. East. Okay. And then that's C, that's B, and this is D. Okay. So I gave you this angle. And that is 58 degrees, 7 minutes, and 39 seconds. What quadrant is B to C in? What quadrant?
4.
Look again.
Oh, 3, excuse me.
Okay. So that means we know what this angle right here is. That's at 85 degrees. What quadrant is C to D in? The one I give you originally. 3. So that means that should be that 27 degrees, 09 minutes, 13 seconds, if our math is right. So I could just take 85, 16, 52, and subtract the 58 degrees. And we should get 27 degrees, 09 minutes, 13 seconds. And that would tell me that all my math is right. You didn't have to go that far, but if it was a test, I probably would just, if I got the time, I'd go ahead and check that last one just to make sure I didn't mess up on one of the ones coming around. So does that make a little more sense now? Maybe. Until you leave and come back Monday after having a 4-day weekend. So if something like this is going to be on the test, I'll review again the following Monday and Tuesday on it. So I'm going to save these PowerPoints. I'm going to email them to you and save. I'll upload the video to my YouTube, and then I'll put it in Blackboard, maybe under Module 5, which is bearing angles and azimuths. So it'll be mine. So Monday and Tuesday I've got CAD. I really need to do a three-sided traverse calculations with you first thing Monday. So maybe take us 20 minutes. That gives them ones that always late time to float in. So I'll probably do that first, and then we'll go right to CAD. Make sure you have your sheets with you. Make sure you don't have to finish them out yet, because I'm going to see if your misclosure's right. So as long as you have preliminary azimuths and you have your, where we did the average all those are for your own. I'll put them in CAD. So we'll start Civil 3D Monday. So we'll do just a three-sided traverse, which is that long sheet. I have somebody's sheet up here, because that's not, unless I might have just made a copy of somebody's. I don't look like, this is 1 to 45,000. Maybe this was somebody's that we worked that problem in class. It was. That 2-day problem. Whose handwriting is this? I think I made a copy and then carried on. That's what happened. I did make a copy of yours and then I picked up where I left off. I saved that PDF from the day before and then picked right back up. So later. All right, so, that's enough for today. I'm gonna save and exit. I'm gonna save as a PDF. This is the review. I'm gonna go ahead and close out a Blackboard too.